Alright, time for another math easy solution. We're going to discuss further into optimization and look at part 3 of the example series. Basically look at minimizing distance in this example. So we look at example 3, basically find the point on a parabola on the parabola y squared equals 2x that is closest to the point 1, x is 1, y is 4, so 1, 4. So basically, first thing we do is just have an idea of how this looks like. Basically, you could move this over. This would be equal to, if you square root both sides, plus or minus square root 2x. And then this one, domain, this can't be negative, so x is greater than or equal to 0. And the graph would look something like this. Yeah, just draw the axis. It would look something like this. This is how the graph would look like. And this is the parabola that's this one here. Basically, if you look at this point here, if we plot 1, 4, well, if we go to 1 here, this one here, when we have 1 inside here, we're going to have y of 1. Is this going to equal to plus or minus square root 2? And then so that's going to be somewhere here. So 1, 4, the 4 is going to be higher than the parabola. So it's going to be somewhere, let's just say, here's 4, this is 1. So we'll have this point, and this will be 1, 4 here. So now we want to know the closest point on this parabola. So it's going to be somewhere like this. So you could just look at it. It should be something like this. Let's plot this one. We'll call this x, y, this point. So now we just have to write down a distance formula. So this is the distance. We'll call this d. And then basically let's draw a right angle across this so that we could use the Pythagoras. And then this point here, this one, well, this length is y, and then this point here is x. This is 1 here, so this distance is just going to be, this one's just going to be x minus 1, and this one here is just going to be 4 minus y. This is a y, not an x. So now we just use Pythagoras to write down the formula for d, and then we could minimize d squared. So d squared is equal to, this one's just going to be 4 minus y squared using Pythagoras theorem plus x minus 1 squared. So now next thing to do is basically, this is a function of y and x, but let's make it a function of one of them only. Well, the easiest way is just 2x here. We could just plug that in here, so we know that x is just equal to y squared over 2 because it's on this point. So this point's on the parabola, so it has to fit this equation. So we plug this one inside here. We're gonna get d squared is equal to 4 minus y squared plus, and in this case this is gonna be y squared minus 2 squared here. Now I'm working with d squared just because I don't want to deal with square root of d everywhere. So for now we're just gonna try to minimize this function. If you minimize, this one's gonna be the same thing as minimizing d by itself. And so if we minimize, so yeah, so we minimize this one, d squared is the same as minimizing d, and then we get the shortest distance. Basically, we use our critical points, local max, minimum, whatnot we learned from before. So let's just call this one, I'll just call this f of y here. So we just need to minimize this because I don't want to deal with the square root stuff. It's going to be the same thing. So now we just minimize f of y. So we take the derivative, f of y squared just going to be equal to, well, this is going to be 2, 4 minus y, and then this is just going to be negative 1. And then when we do derivative of this side here, we're going to get, this one's going to be 2 y, yeah, y over 2 minus 1, and derivative of this is going to be 2y over 2, using chain rule. So we have this function here. Now we could just simplify this further, multiplying this out. This is going to be, well, negative 2, 4. This is going to be plus 2y. Just multiplying this inside. And then we're going to get, well, this cancels here. We're going to be y cubed. So this is going to be plus 2. The 2's cancel. Well, y cubed over 2 minus 2y. So now as you see, this cancels here, this cancels, so now this cancels here. We're going to be left with y cubed minus 8. Now we get the critical points here. Basically we set this equal to 0, and this just solve for what y is here. So we're going to get y cubed equal to 8, and this is true only for basically y is equal to 2, because 2 times 2 times 2 is 8. Now we just have to see if this is truly a minimum, not a maximum. But this is what the right answer would be. But let's just for getting a further proof of this, so we'll have a 2 here if we have y in this case, because it's a function of y. Remember, this is just f of y here. We just want to see if it's increasing or decreasing in these two intervals. So when the first interval, when y is less than 2, well, it's greater than 0 in this case. Actually, no, ignore the 0. We have two intervals. It's less than 2 and greater than 2. So if we put anything less than 2 in this one, or like 1 or negative or anything, it's going to be negative here. So then this one is going to be f of y is going to be less than 0 or decreasing. And similarly for the second one, for anything greater than it, if you just put a big number, minus 8, 8 doesn't affect it, so this is going to be increasing. So if it's decreasing and increasing, we have a minimum. So it's going to be something like, it's going to be, yeah, I'll just draw it over here, I guess. So it's going to be something like decreasing the whole way. Just draw through this, and then it's going to be increasing. Well, actually, it doesn't have to be at the point, so that's just, so it's going to be something like this, and this is going to be a minimum. So then basically that's our distance. So at y equals 2, f of y is minimum, and thus yeah, d squared is minimum as well, and this one similarly it goes back to d as well. This is minimum. So at basically y is equal to 2 here. So then at y, so we know that y squared is equal to 2x. So plug in 2 here, we're gonna get 4 equals 2x, and x is equal to 2. So basically, it's the point, if we were to draw this back, the point closest to it, if this is y squared, this is x, this is y. So then at the point 1, 4, the closest point is just 2 and 2. And this is the closest distance here. And also, I just wanted to graph that function y cubed minus 8 just to make sure we do have a minimum. And as you could see here, actually I'm graphing the wrong one, that was a derivative. So we have to graph d squared. This one's going to be 4 minus y squared plus, this is going to be y squared divided by 2 minus 1 all squared. Let's see how this would look like here. So just graphing here, and as you can see, it is a minimum at 2, and it's actually equal to 0 then. Or no, it's not equal to 0, but it's close. So as you can see, it's the minimum here. It looks pretty ridiculous, this curve, but as you can see, it actually goes to a minimum. You have to zoom in to see it, but its minimum is at 2, and we do have a minimum distance. Well, that's all for today. This is a useful example on basically minimizing distance and whatnot. You can download these notes, like always, in the Dropbox link below. Let me know if it doesn't work. Well, that's all for today. Hopefully you learned, and stay tuned for another Math Easy solution.